Good morning, John Gilkison here. It's Tuesday, April 27th, 2021, and I wanted to shoot that follow-up video I talked about in my last video about the Cybertruck and the 0.10 drag coefficient. Let's be clear, when I did the last video, I didn't know that this graph was for a Cybertruck, but it made sense. It was a follow-up graph for projects Phil and I had been working on. He just didn't say that. And anyway, just for clarity's sake, I'm going to show you what we're talking about here. You have a Cybertruck, and you're towing a light-duty trailer, which completes the form. It allows the air to come off the truck and then really reduces the wake area of the vehicle back behind. Now, I don't know, but I think possibly the rear wheels of the Cybertruck might need to be paneled in too. But this is just a drawing. And as you can see, there's an accordion-like structure in between the truck and the trailer, covering the tow hitch area. And that's a gap filler, and that's of critical importance to make this shape work as efficiently as it can. But towing this light trailer would reduce the drag coefficient of a Cybertruck down from 0.30 down to 0.10. That would be the goal. And that's about as low as you can go for ground transport. But the benefits of it are just miraculous, beyond belief. And that's what this video is about. So what I did is I chose to model the middle range variant of the Cybertruck, which I project to have a battery of 130 kilowatt hours capacity, and that it would that would be the $50,000 variant that I call the middle range one. And it's likely to be the most popular one. The cheaper one won't come out for a while, a year or two afterwards, and it only has 250 miles of range. So this is likely to be what we'd consider the standard range truck that most people will opt to buy. Yes, they'll have a 500 mile range version with a 200 kilowatt hour battery pack, but it's, I think, about $20,000 more expensive. So there you have it. So what Phil did, and this graph you've seen before, is he sent me this graph right here, and it models a 0.1 coefficient of drag. And what you have here is, on this side, up and down here, is kilowatts. And then the bottom line is miles per hour. So for example, just to pick an even number out, right here, the truck's requiring 15 kilowatts to do 70 miles per hour. Okay? So the first thing I got to looking at was with this is there's a 5-step process to generate miles per gallon. And of course you generate a lot of other figures in the process, but so I wanted to generate this table right here. See if we can stabilize this video by leaning the post up against the hold on a minute. Lost my tape on my chart. So anyway, first thing I did was just list the kilowatts and the miles per hour, and then I listed the kilowatts required to do those speeds in the second column. And once you know you have a 130 kilowatt hour battery pack, which I state up here, you can then generate the hours. In other words, you divide the kilowatts, in this case here, 70 miles per hour, 15, you divide it into 130. And that means you can travel at 8.66 hours at that speed before you deplete the battery. And that automatically tells you the range. So now the vehicle has 607 miles of range at 70 miles per hour. And it's using 214 watt hours per mile, and it's operating at 153 miles per gallon. Now let's be entirely clear here. This truck has a 300 mile range, stock, without towing this trailer. So now all of a sudden at 70 miles per hour you have double the range, and you've cut the energy consumption in half. And this is all because, and now please note on this graph here, Phil has allowed for the increased weight of the trailer. So the rolling resistance here in blue is much higher than you normally see on these graphs. And even so, this aerodynamic package is far more efficient, even with increased rolling resistance. So that was one of the first things I looked for, was the 50-50 point, and I'm figuring it's somewhere around 90 miles per hour. In other words, rolling resistance is 50% of the total road load. So that's normally in vehicles is around 60 miles per hour. But then I went looking for my second thing that I like to look for, and that's where you're no longer getting 100 miles, where you're no longer getting over 100 miles per gallon, the 100 mile per gallon point. How fast you have to be traveling before the efficiency is reduced down to 100 miles per gallon. Well, in the case of the Cybertruck, the truck is not even rated to get 100 miles per gallon at normal highway speeds. Stock at probably around 70 miles per hour, it's only getting from 75 to 85 miles per gallon. So, but towing this trailer combination, which reduces the aerodynamic drag down to 0.10. What happened was, and I was very surprised by this, is I couldn't find the 100 mile per gallon point. The truck is just rated to do no more than 130 miles per hour anyway, and at 130 miles per hour, it's getting, let's see if you can see this, it's getting 109 miles per gallon. It's using 302 watt hours per mile, and it's still got 430 miles of range, which is 130 miles more range than it has not towing the trailer. So much for this theme of TFL trucks, the fast lane trucks, that's what it is, and engineering misexplained that electric vehicles have a trailer towing problem. I'd like to have this trailer towing problem, wouldn't you? Still getting 109 miles per gallon, 130 miles per hour. Personally, and I told Phil this, is I wouldn't drive the truck 100 miles per hour, not towing a trailer, let alone try to do 130 miles per hour towing a trailer. Although I'd have no problems doing normal speeds, 70 to 80 miles per hour, that'd be fine. That wouldn't bother me any. But I find once I get much over 75, 80 miles per hour, the time horizons really close in on you. Things are just happening so fast. Something way up ahead's all of a sudden right there within seconds, and you got to pay attention all the time. It makes you nervous to do those. It makes me nervous to do those high speeds constantly on the highway. Not only that, I'm nervous about getting pulled over and given a ticket. So, and I like to just set the cruise control and go. And so, this is phenomenal performance. Now, I published a blog on this called 150 mile per gallon Cybertruck towing a trailer. The blog is published on our Facebook Electric Vehicle Organization EVO page, and I'm going to try to publish it on some other Facebook pages that have to do with electric transport and so forth. I just haven't done it yet, but I wanted to shoot this video and get it uploaded today because I wanted you to see this. This blew me away. I knew it was going to be good, but when I generated this table right here, which didn't take me long, by the way, I probably only spent 10-15 minutes generating this table once I had the routine set up. But we got a coefficient of drag of 0.10, 36 square feet of frontal area, but that makes the CDA 3.6. So this reduction from a coefficient of drag of 0.3 to 0.1, it's just it's a leap. It literally is. It doubles the efficiency of the vehicle. And you know, a trailer like this, a person might have reason to hook it up and go someplace. It could even have extra batteries. You know, you might be able, instead of going 600 miles, you could have extra batteries in there to go another 400. You know, and you could have a 1,000-mile range electric truck. Or you could just go 600 miles, which is more than a day's driving, and you could tow extra gear. It could even be made into a camper of some sort. That's for others to do, but this is what you're looking at right here. 150 mile per gallon Tesla Cybertruck. I'm going to leave you right there. We'll be seeing you on down the road, everyone. Happy electrons. Bye-bye.